Welcome back. So today we will discuss about chapter one of the most important chapter in physical chemistry, that is electrochemistry. So the total electrochemistry we are going to study in three parts. So in part 1 we will be having discussion on electrochemical cell, so especially on galvanic cell and EMF of the cell and EMF calculations, the Nernst equation and Nernst equation calculations. So all these we'll discuss. So first, electrochemical cell or galvanic cell. So as you know already that an electrochemical cell is a cell or it's a device which converts the chemical energy of a spontaneous redox reaction which is occurring in the device into electrical energy. So this is called as electrochemical cell. So chemical energy is converted to electrical energy. So in reverse, if you use the electrical energy to perform a chemical reaction, then it is called as electrolytic cells, which will be discussed in the next part of our electrochemistry. So example we'll take. So one of the good example is zinc dipped in zinc sulfate and copper dipped in copper sulfate. Zinc dipped in zinc sulfate, copper dipped in copper sulfate. This is one of the galvanic cell, most famous galvanic cell. So in any electrochemical cell, as we know, it will contain two electrodes. One is called as anode, another one is called as cathode. So where anode always oxidation will occur, always keep in mind anode always oxidation, cathode always reductions will occur. Reductions will happen in cathode, whereas anode oxidation will occur. So in this, if you take zinc to zinc sulfate, here zinc is converted to zinc plus 2 by loss of 2 electrons. It is oxidation. So our zinc in zinc sulfate act as anode. Next, where copper dipped in copper sulfate, our copper plus 2 ions of the copper sulfate will take up 2 electrons and forms copper. Here copper in plus 2 oxidation state is reduced to 0. Reduction is happening. So copper will act as cathode. So next, how to notate a cell notation. How to notate a cell notation, how to represent a cell, which is most important. When you are representing any cell, first you should represent anode, followed by two vertical lines, then followed by cathode. This is how you need to represent a cell. Inside the anode also, when you are representing the cell, first you should represent the metal of the anode, followed by one vertical line, then its metal ion. Metal followed by metal ion. So this metal ion indicates the electrolytic solution because metal ions are present in electrolytic solution. So then cathode, when you are representing, first you need to write the metal ion, then followed by the metal of the cathode. So this is the way to notate the cell. So let us take our cell. So where zinc dipped in zinc sulfate, copper dipped in copper sulfate. This cell notation, if you write, first, as we know, zinc in zinc sulfate is acting as anode. So first you should write the metal zinc, followed by metal ion of the zinc is Zn plus 2. Again two vertical lines which indicates a Sol bridge. Again metal ion of the cathode is copper to copper sulfate, so you should write Cu plus 2 followed by Cu metal. So this is the notation of the cell. So any cell that we are going to write, so the every cell is notated in the same manner. So this is what you need to remember in the notation of the cell. Always anode followed by cathode, the two anode metal followed by its metal ion. Again cathode also metal followed by its metal ion. This is must be remembered. So when you are treating any cell you are not treating, this must be followed. 100% it should be followed. If you are not following this, your cell notation will go wrong. For example, if I written, if example nickel 2 nickel plus 2 is notated with the, let us say, Zn plus 2 to Zn. If this cell is given for you, which is an anode and which is acting as cathode, automatically first whichever you are written, that will act as anode. So second will act as cathode. So this will act as anode and this will act as cathode. So anode oxidation will occur. So when nickel converted to nickel plus 2 with losing of 2 electrons. So this is cathode, where reduction will occur. Reduction is Zn plus 2 will take up 2 electrons, will form Zn. So the overall reaction, if you want to write, the overall reaction will become 2 electrons will cancel. So the overall reaction will be, so nickel plus Zn plus 2 gives rise to nickel plus 2 plus Zn. This is the way to get the overall reaction. Overall reaction when cell notation is given. So this is the way to represent when overall reaction is given. If overall reaction is given, then this is the way to represent a cell notation. So two different methods. So this is very important. So next, EMF of the cell. EMF of the cell, electromotive force. EMF of the cell. EMF of the cell or electrode potential of the cell, it is calculated by using the formula E0 cell is equal to E0 of cathode minus E0 of anode. This is the way to calculate the EMF of the cell, or which is also called as cell potential. E0 of cell is equal to E0 of cathode, and once you know cathode electrode potential, anode electrode potential, you can calculate the cell potential. Or we can write E cell is equal to E of cathode minus E of anode, where E is the electrode potential, E0 is the standard electrode potential, not indicate the standard electrode potential. Standard electrode potential, which is also called as cell potential, which is also called as EMF. Standard electrode potential, we can call it as EMF or cell potential. Why it is called as standard? Why? Because whenever it is given as E0, if it is given as E0, the meaning is it is calculated. Your electrode potential is calculated by using standard hydrogen electrode. Your E0 is calculated by using standard hydrogen electrode as reference, which is taken as anode, and reluctant potential is calculated. That's the meaning. Next, our condition is your concentration of the electroactive species will be 1 molar. Next, it should be contained at STP, standard temperature and pressure, maybe at room temperature 27 degrees and pressure of 1 bar. So this should be maintained. If these conditions, if you have calculated the electrode potential or cell potential, then it is called as standard. So hope you understood. Standard means should be SHE. It should be calculated using standard hydrogen electrode as anode. Should be 1 molar. It should be done at 1 STP conditions. So what is E cell? E indicates other than standard. That means if the electroactive species is not exactly 1 molar, other than 1 molar, maybe 0.01, 0.05, 0.001, whatever, other than 1 molar when you take, then it is called as E, that is electrode potential. So how to calculate if this is the way? Next, if E0 is given, if E0 of an electrode, or if it is a cell, whatever it is, if E0 of a single electrode, let us say Zn plus 2 to Zn, E0 is given, E0 is given, then how to calculate its E? That means the meaning is, if standard cell potential or standard single electrode potentials if they are given, how to calculate their electrode potentials at any concentrations other than 1 molar concentration, other than 1 molar, then that is maybe greater than 1 molar or maybe less than 1 molar, then how to calculate this. So there is an equation, very famous equation, which is called as Nernst equation is used. So the Nernst equation says E of any single electrode or E of a cell you can take, or E of any single electrode, that is M plus M to M single electrode, it is given as E naught cell minus 2.303 RT by NF log Q. So this is called as Nernst equation. So the use of Nernst equation, as I said very clearly, that when standard electrode potentials are given, to calculate the electrode potentials at any concentration, you should use this equation. What is this Q here? What is this R here? R is gas constant, T is temperature, F is Faraday's constant. So R, earlier as we know, it is 8.314 and room temperature generally taken 27 or 290, that is 300 kelvins. So next F is Faraday's constant, 96,500 coulombs. If you apply all these values, so you can simplify this equation. So the simplified equation, if you can write, that is E cell is equal to E naught cell minus 0.059 by N log Q. This equation we can use to solve the problems, very important equation. Log Q. What is this Q? Q is reaction coefficient. It is the concentration of products by concentration of reactant raised to the stoichiometric coefficients. So here the products and reactants must be taken as only ions. Only ions should be taken, other than ions the concentration should not be taken. Next, when you take for single electrode potential, the equation becomes E naught of M plus N to M minus 0.059 by N log 1 by concentration of M plus N ion. So this is for single electrode potential. I cannot write log Q. I cannot write log Q because Q indicates for a reaction. It is only single electrode potential, so you can write 1 by concentration of M plus N ions. This is for single electrode potentials. So using this we can solve many equations. We'll solve the problems also using this. So two more very important relations we need to remember before going to solve the problems. So one is thermodynamics in electrochemistry, that is delta G is equal to minus NF of E cell, or delta G naught is equal to minus NF of the E naught cell. Most important, gives free energy relation to electrode potentials or cell potentials. So next, E naught cell is equal to 2.303 RT by NF minus 2.3 RT by NF log Kc. This is applicable when it is given as equilibrium constant. If your reaction is at equilibrium, then only this reaction can be used, otherwise no need of using this reaction. Equilibrium constant. See, the main difference is here it is Q, here it is Kc. Q indicates reaction coefficients at any concentration, even though if it is not at equilibrium, but this is when you obtain equilibrium, Q will become Kc. So when it is at equilibrium only, okay, that means Kc is nothing but concentration of products by concentration of reactants and only raised to the stoichiometric coefficients. So this is also the most famous equations. So we'll solve some of the previously asked IIT as well as NEET questions. So So using all these concepts that you have dealt, using the cell notation, using this Nernst equation, using this. So let's solve the first question. The reaction, so he has given some reaction here, occurs in which of the following galvanic cell. So if you see the options, so all the options are given as cell notations only. All the options are cell notations only. That means cell reaction is given, and he asked you for cell notation. So how to notate a cell? We have discussed how to notate a cell. When you are notating any cell, first you need to anode, then you should notate the cathode of the cell. When notating anode, within the anode, first metal followed by metal ion of anode, then in the cathode, metal ion followed by the metal. This is how you need to notate the cell, right? So let us select which is anode and which is cathode from this reaction. How to know which is anode and which is cathode? So only thing is, anode, you know, oxidation will occur. At cathode, reduction will occur. So whichever the species is undergoing oxidation, so it is acting as anode. Then whichever the species which will undergo reduction will act as cathode. So let's see, hydrogen, the reaction is converted to H plus. Here hydrogen oxidation state is 0, whereas H plus oxidation state is plus 1. So 0 to plus 1, you can see there is a decrease in oxidation state. When there is a decrease in oxidation state, increase in oxidation state, 0 to plus 1 is an increase. Increase in oxidation state is called as oxidation. So it is acting as anode. So our anode is hydrogen to H plus. So first you should write the metal, that is hydrogen to H plus. So katam. Next, cathode. Let's select cathode now. AgCl is converted to Ag and Cl minus. In AgCl, Ag oxidation state is plus 1, chlorine oxidation state is minus 1. Whereas here Ag oxidation state is 0, chlorine again minus 1, there is no change in oxidation state. So plus 1 is becoming 0, means it is reduced. So where there is a decrease in oxidation state, it is reduction, it acts as cathode. So it acts as cathode. Whenever it is cathode, first you should write the metal ion. Metal ion is AgCl, or I can write Ag plus to Ag. So whichever of these four options represents this, that will be the exact answer. So let us check out once. If you see the first option, hydrogen using platinum, here why he has given platinum is, or platinum is an inert electrode. So on its surface the reaction will occur, because it's a gas, the reaction will occur at the surface of this metal. So it is just an inert electrode, it won't participate in inert metal, it won't participate in the reaction. So not to worry about the platinum. Okay, so H2 to HCl, HCl means H plus only, so H2 to HCl, yes, correct. Next, AgCl to Ag, AgCl, yes, AgCl only to Ag, correct. So your first option is correct. So you may ask me, why not second option? Why not second option means, in the second option H2 is given to KCl, H2 is not converted to K plus, it is converted to H plus. Third option absolutely wrong, there is no hydrogen in the third option. Fourth option, if we see, here it is AgNO3 is given, but he has taken AgCl, so it also goes wrong. So our answer is first. So here the method is cell reaction is given, cell notation is being asked. So first one is solved, easy one. Second one, so let's take the second one. Question, given that standard electrode potentials of Cu plus 2 to Cu is given, and as Cu plus 2 C plus 2 C is also given, Cu plus 2 to Cu plus is being asked. So let us take it, what are being given. E naught of Cu plus 2 to Cu is given as 0.34, and E naught of Cu plus 2 Cu is also given as 0.522. You are asked with E naught of Cu plus 2 to Cu plus is question mark. So to solve this type of questions, so we cannot use E cell is equal to E naught of right of cell minus E naught of left of cell, that is E naught of cathode minus E naught of anode. We cannot use this because is not formed any cell. That is the first thing. As well as there are only one electrode potentials are there, so we cannot use it. So when you cannot use it, so we will use one more very important concept to solve this, that is delta G, because for every reaction to occur there should be some amount of Gibbs free energy will be released. So this equation will be used to solve this type of problems where only one electrode potential will be given, only one metal will be given in the different oxygen state, 2 to 1, 1 to 0, 2 to 1, like this. So to solve this type of questions, we will use this concept delta G is equal to minus NF of E naught cell. For that, first you need to write the equation involved in this. So the equation involved in this is Cu plus 2 is converted to Cu. So to convert this, you need 2 electrons to be accepted by Cu plus 2. In this, Cu plus 2 is converted to Cu plus it is. So Cu plus converted to Cu. It has to gain 1 electron. In the third case, Cu plus 2 is converted to Cu plus. Again it has to take 1 electron. So if I take, this is my equation number 1, first one, equation number 2, equation number 3. So here delta G naught, let us say delta G naught 1, delta G naught 2, and this is delta G naught 3. Gives free energy of the equations. So the question is, this is being asked. So let us see, can we get the third equation from the first and second? Is there any possibility? Yes, there is a possibility, because we don't need copper and copper, Cu and Cu in the final equation. You can do it minus, you can subtract the equation number 1 minus equation number 2. This will be cancelled. So 2 minus 1 electron, you will get 1 electron. Cu plus T is as it is. You will get minus Cu plus at the left side. If you send it to other side, it will become plus Cu plus. That means equation 3 you can get by subtracting equation 1 minus equation 2. In the same way, delta G naught of 3 is equal to delta G naught of 1 minus delta G naught of 2. This is the key to solve this question. So first you need to write the equations, then you should get whatever the electrode potential is being asked, that equation you need to get. So you need to see either it is first minus second or first plus second, sometimes depending upon the equation. Then you need to equate it. 3 is equal to 1 minus 2, or in some equations you may get 1 plus 2 also. So it depends upon the question. Then let's apply this. Delta G is equal to minus NF of the delta G naught 3. For this, minus NF of the naught cell minus N is number of electrons is 1 into F into E naught of our cell is Cu plus 2 to C is equal to, again, delta G naught 1 means this is the G naught 1 minus NF, N is 2 electrons clearly, minus N is 2 into F into E naught is 0.34 minus delta G naught 2 is nothing but minus NF, again minus N, here it is only 1, so 1 into F into E naught is given 0.522. So let's solve this. If you solve this, we will get the answer. Simply we will get the answer now. So let's solve it. So F is common in every word, and the left hand as well as right hand side, so we can cancel this F. So minus into E naught, so that is minus E naught of Cu plus 2 to Cu plus is equal to minus 2 into 0.34 is minus 0.68, minus into minus it will become plus 1 into 0.522 0.522. So that is E naught of Cu plus 2 to Cu plus is equal to, if you send this minus other side, it will become 0.522 minus 0.522 plus 0.68. So this is nothing but you will get plus 0 point plus, if you subtract this you will get plus 0.158. so this will be your answer. So let us check out whether the option is given or not. 0. Yes, so the answer is exactly correct. Your answer is B. So this is how you need to solve this type of questions. So this type of questions, when you are solving, you are given with only one type of electrode. When it is given only one type of metal, Cu plus 2 Cu, Cu plus 2 Cu, any type of metal with different oxidation will be given. So you need to solve by using this method. You need to use delta G naught, and you should write the equations. So whichever the equation that is being asked, you need to equate it with using other two, that is either it is 1 plus 2 or 1 plus 3 or 1 plus 2 or 1 minus 2 or 2 minus 1 sometimes. Then just apply that delta G naughts and solve it. So next question we'll take up our next question. So next question. So this is our next question. Similar type of question that is being given. Given the half cell reactions are given, Mn. Again same like previous question only. Mn to Mn plus 2 to Mn plus 3 to Mn plus 2, Mn plus 2 to again Mn plus 3 and Mn. So all are Mn only. So similarly like last problem, we need to solve it now. Same like last problem. So let us write this. First, Mn plus 2 electron gives rise to Mn. E naught is given as minus 1.18. Again let's multiply it and write. 2 into Mn plus 3 is 2 Mn plus 3 plus 2 electrons gives rise to, I am multiplying it by 2 and writing it. So 2 into Mn plus 2, that is E naught is given is plus 1.151, sorry 1.51 only, plus 1.51, right? So what is being asked? E naught for 3 Mn plus 2 gives rise to Mn plus 2 Mn plus 3. So as I said earlier, you need to get, this is equation 1, equation 2, equation 3. You need to get equation 3 using 1 and 2. So how can you get equation 3 from 1 and 2? So just you check out, if you subtract this, can you get it? If you can subtract 1 minus 2, is there any chance? 2 electron will get cancelled, there will not be any electron. So you will get Mn plus 2, 2 Mn, 3 Mn plus 2. So you will get Mn plus 2 at this side and 2 Mn plus 2 at another side. It will become minus. So when it comes at other side, it will be 3 Mn plus 2. So you get this. Okay, 2 Mn plus 3, when it's at it other side, it will become 2 Mn plus 3. Correct, minus, it will become plus. So you can get third equation from 1 minus 2. So how to get it? So you can take delta G is equal to minus NF of the E naught cell. This is how you need to use it, and you should solve this problem. So let's solve it using this. That is equation number 3, minus NF N. How to get the N from this? Because number of electrons are not given, you cannot take it as 0. So number of electrons are not given. So this equation has two equations. There are 3 Mn plus 2. Out of 3 Mn plus 2, 2 are converted to 2 Mn plus 3 and 1 is converted to Mn. So out of 3 Mn plus 2, 2 Mn plus 2 are converted to 2 Mn plus 3 and 1 Mn plus 2 is converted to Mn. There are two equations involved in it. We got two equations involved in it. So if you see 2 2s are 4 and 3 2s are 6. So plus 4 is become plus 6, means here we have 2 electrons. We have 2 electrons here. 2 Mn plus 2 converted to Mn, again we have 2 electrons here. So the electrons are 2. On an average the electrons are so minus 2 into NF F into E naught cell, that is what we need to calculate. E naught is equal to minus N is how much here in the first equation is 2 into F into E naught is minus 1.18 from the first equation, then minus of NF E naught cell for the second equation. N is 2 again, 2 into F into E naught is plus 1.51. So if you solve this, you will get the answer. So let us solve it. See, in every equation F, and there is F is common. F will get cancelled. So minus 2 into E naught minus 2 E naught is equal to minus into minus plus 1 into 1.18, that is it will become 2.36, minus into minus it will become plus 1.51 into 2, so you will get 2 ones are 2, so it will get 3.02. So that is minus 2 E naught is equal to, if you add them it will get 5.38. So that is E naught is equal to 5.38 by minus 2. So where you will get answer is minus 2.69. So minus 2.69. So this will be the answer. So you have, in both cases you have minus 2.69 as the answer. So when you have both the cases you have minus 2.69 as the answer. So next, how to determine the answer? So whenever you have to remember, the most important thing is when E naught is negative, reaction does not occur. When E naught is positive, reaction will occur. So he has given E naught, you got negative, automatically reaction will not occur. That will be the answer. Whenever E naught is positive, then only reaction will occur. So this will not be wrong. So option A is correct. So this is the question. So let's take the next question now. Hope you understood. Similar type of question that we have solved. Last question is also same. So when it is only one metal ion is given, just you take you have to take the equation, then you need to relate how to get the third equation from first and second, then just apply delta G naughts values here and get the answer. So the only new concept is E naught if it is negative, cell reaction will never occur. E naught if it is positive, cell reaction. This is applicable to every cell now. Next question. So E naught is given that E naught of O minus 2 to H2O, O minus 2 to H2O is plus 2.3. E naught of H2O is 2.05. E naught of bromine is given 1. So some E naught values are given for some metals. Which is a strong oxidizing agent? The question is, which is a strong oxidizing agent when E naught values are given? If you see the E naught values, all the E naught values are reduction potentials only. All your E naught values, 3 will become 0 here, reduction potential. This is also reduction potential, 0 is becoming minus 1. Here also minus 2 is becoming 0 is becoming minus 2. O2 is 0, 0 to oxygen is minus 2 here. All are reduction potentials only. When all are reduction potentials are given, so higher is the reduction potential value, higher is the reduction potential value, greater is its oxidizing power, greater is its oxidizing power. That is, it acts as good oxidizing agent. Good oxidizing. This is how you should remember. Very important. Higher the value, greater is oxidizing power. Good is the oxidizing agent. If lower is the reduction potential, it is not a good oxidizing agent, but it can act as reducing agent. It can act as reducing. It's better is the reducing agent. Lower the value, better is the reducing agent. So higher the value, greater is the oxidizing capacity. So we ask with the oxidizing agent. Oxidizing agent means greater is the value. Whichever is the greater is the value, that will be the answer. So the greater value is of 2.05. So when it is 2.05, your answer will be H2O8. So simple. So next. So let's see this also. First we'll see this, we'll go further. Next one. Cr plus 3 to Cr is 0.74, 1.51 for MnO4, 1.33 for Cr2O7, Cr is 1.36. So which is the strongest oxidizing agent will be? Strongest oxidizing agent, I said earlier only oxidizing capacity. So higher is the reduction value, higher is the reduction potential value, greater is its capacity to oxidize. So again oxidizing only others, so higher reduction potential, which is the highest reduction potential, that will be your answer. Higher reduction potential. So 1.51 is given, here it is 1.33, so this is a higher reduction potential. Out of 4, higher reduction potential. So this is the strongest oxidizing agent. So which is the oxidizing agent now? MnO4. Again there are two options in this. You see, either it is MnO4 or Mn+2, because whichever it is reducing, no, that will be your answer. MnO4 is reducing to Mn+2, so this will be answer. If it is given Mn+2, it is a very good oxidizing agent. It's a very good reducing agent. So MnO4 is the correct answer. Right? Hope you understood. Next question we'll take up.